Hi everyone, I teach both machine learning classes, artificial intelligence classes, and classes on Arduino programming. This is a little Arduino device. What the Arduino does, for those not in the Arduino class, is it interacts with things that are physically in the world, right? So it can do things in the world. It's kind of like a robotic device, or kind of the basics of a robotic device. And this short talk merges the two. So this is the Arduino Uno, as I mentioned. I'm going to set that aside to talk about what's called the Jetson NVIDIA Jetson family of computers. This is one such device in the Jetson family. This is the Jetson Nano. It's around $60. This one here is the Jetson TX2. It's around $200, around that line. And these, as well as slightly larger other computers in this family, power hundreds of real-world devices. So they're like, compared to this, they're putting artificial intelligence and machine learning to these devices. For example, John Deere, the tractor company, has a product called See and Spray. The tractor is traveling around 7 miles an hour. There are 30 cameras facing downward, and through artificial intelligence and powered by the Jetson computer, these small computers, they can distinguish between a weed and a plant crop, and they can spray herbicide on that weed. So that's pretty cool, if you like herbicide, I guess. There's a company called Harvest Crew, which has a strawberry picking robot, again powered by these small Jetson computers. Everything's run on those Jetsons. They can identify whether they can find a ripe strawberry and manipulate a robotic arm to pick that strawberry. Companies like Oxford Nanopore and Smarter are using Jetsons to do DNA and RNA sequencing of pathogens. The Smarter one even uses this small $60 NVIDIA Jetson Nano to do that work. There's a company called Valerion, which is using autonomous AI inspection drones powered by a Jetson to inspect damage to wind turbines. So by autonomous, there's no human in the loop. These drones go up, look at the blades, and determine on their own whether they're damaged or not. This is really a big problem for wind turbines. Those blades are traveling at 180 miles an hour. They look like they're going slow, but it's just because of their vast size, you don't realize how fast they're going. And they continually hit dust particles in the air. Doesn't seem like a big problem with dust particles, but there's so many of them that they erode the edge of that blade. So these drones can detect that. There's a company called Postmates, which has a Jetson-powered on-demand delivery robot. That's what they manufacture. So the vast applications for the Jetson are quite amazing. So let's compare just briefly the Jetson to the Arduino Uno. So this Arduino Uno, let's put that here, that can operate at about 5 million operations per second. Sounds like a lot. So 5 million floating point operations a second. Sometimes that's called flops. Or that is called flops. It's not sometimes. This $60 Nano is 500 million. So 100 times more powerful than this simple device. And we get to the larger Jetson TX2, and that's 1,300 million. And the biggest product in the line is around 11, the Xavier is 11,000 million floating point operations a second. So that's you can see the vast difference between a simple Arduino Uno and even the most rudimentary product in this Jetson line. So let's go ahead and power up that Nano and see if we can do something at least kind of semi-interesting. So here's that Nano. I'm going to hook it up to a standard webcam here and see if we can do some recognition on images. So let's connect things. Here's a power cord. Let me just connect that power cord. Let me unwind this camera. Okay, I got the camera plugged in. And in order to see what's happening, I'm going to connect this to a laptop just so I can be able to type on a keyboard and type things in and see a display of what's going on. So everything's being done in this Nano. The laptop's just being used kind of for display purposes. So let me go ahead and connect that up if I can find the right cord here. Okay, that's all I'm going to use for this experiment. So I'm going to just set this aside, and again, let me just kind of angle I'm just going to use my MacBook not to do anything interesting, but just to serve as kind of a display. So let me go ahead and turn on my laptop. All right, so here I am on my MacBook, and I'm going to log in remotely to that Jetson Nano. And let me just see if I can, there's the command SSH, and my username on the Nano is Raz, and that's the address of the Nano. So it'll allow me to connect. Let me type in my password. Okay, and I have a program here that I'm going to run. Again, this is on my little device there, that $60 device. It's not being run on my laptop, but I'm going to run this program I have called Docker DLA run shell. Okay, and that starts this little program that gives me a kind of a user interface so I can use the Nano a little bit better. I could connect a monitor and a keyboard directly to that Nano, but I'm doing this kind of more remote way and using the laptop. All right. And let's go now to that device here, and now I have yet another Okay, and I'm going to work on this classification task. This is a simple task that's given to us by NVIDIA just to help us get started with this device. I'm just going to use something that came with sort of the device. All right, and it's just getting started, and it's going to use that webcam as I mentioned. So let me just run this code. And now I'm going to connect the camera. And the light on the camera came on, so I know the camera works, and it also says camera created. And what this little program is going to do is it's going to look at my hand and determine if I'm giving a thumbs up signal or a thumbs down signal. So that's my goal here. This is just setting everything up. The model I'm using for those in the machine learning class is this one called ResNet 18. So it's a convolutional neural net. Again, the Arduino class people don't know what that means. I'm just trying to get to audiences somewhat interested in this area of putting machine learning on small devices. Let me execute this one. This little asterisk here just simply means that it's working on that cell. And for those not that knowledgeable about machine learning, if you've heard about deep learning in the press, this is deep learning. So, or neural networks, or things, if you hear topics like this about artificial intelligence, machine learning, deep learning, neural networks, it's all what we're doing right here in this very simple example. Okay, so everything is created now, and I'm going to now get it up and running in a little user interface. So there I am, and that looks, you can see my window and my hand on the keyboard. Let me move the, let me go here, I guess. Give me a second. We'll call that good. And what I can do is give a thumbs up. Let me back up a bit. Or a thumbs down. Let me get out of the way here. And it'll recognize what it is. to train it, I've done 32 pictures of thumbs up and 32 thumbs down. So let me just add a thumbs up here just to show you what it's like. So this is a thumbs up, and I'm going to say that is a thumbs up. Let me do another one here. Let me do it some further back here. There's a thumbs up. And I'll do one more. Let me put it here. That looks good. All right, so I have 35 thumbs up. Let me do a thumbs down here to get to 35. All right, so now I can train this. Actually, let me go more, make my training a little longer. Okay, and now it's done training, and let me put my thumbs up here, and you can see it's pretty unclear about thumbs up. Let me move to the side here and do a thumbs. Hard to get a good image on my, let me move this a little bit here to there. That's probably better. So that it thinks it's a thumbs up. Maybe. Definitely a thumbs up. Let me do a thumbs down. So it recognizes the thumbs up. Maybe. Let me go back. Let me move my tripod. Kind of noisy. Let me move here. Thumbs up. Thumbs down. Thumbs up, thumbs down. So the program was able to train just on 70 images. There was just 35 images of thumbs up, 35 of thumbs down, and just from that limited little set of pictures, it was able to produce something. It was able to learn what a thumbs up and a thumbs down were. So it's pretty interesting that you can do something like this in just a pretty inexpensive device. That's all I wanted to show. I hope this was interesting and spurred your interest. So if you want to do more, either on the Arduino side, if you want to learn about machine learning, this is a great device. Or if you're a machine learning person and want to know, well, how can I build things that interact with the world and might do stuff? Not just recognize thumbs up and thumbs down, but do something with that knowledge. So I hope this was helpful. Take care. Bye.